The National Electrical Code does not explicitly prohibit a daisy chaining method for connecting 2x4 fixtures. However, it does specify requirements for wiring methods in general. Article 300.13 states conductors of different systems or circuits, or of different voltages, shall not be placed in the same raceway, cable, or enclosure unless specifically permitted. Article 300.3c states conductors shall not be installed in such a manner as to short-circuit or open-circuit the circuit. The inspector's interpretation could be that by skipping the second fixture in the row, a parallel path for current flow is created, potentially creating a short-circuit condition if a fault occurs. By using the factory-installed whip to return current to the first fixture, a loop is effectively created, which could cause the circuit to trip if the loop resistance is too high. To address these concerns, alternative methods can be considered. Firstly, use a junction box. Install a junction box between each fixture and run separate conductors from the panel to each junction box. This ensures that each fixture is independently wired. Secondly, daisy chain without skipping fixtures. Connect the fixtures in a straight line, daisy chaining from the first fixture to the last. This method reduces the potential for short circuits and open circuits. While the NEC does not explicitly prohibit the daisy chaining method described, the inspector's concern is valid based on the general requirements for wiring methods. It is advisable to follow the alternative solutions provided to ensure code compliance and safe operation of the lighting circuit. Considering these points, let's delve into the intricacies of electrical wiring and code compliance to fully understand the situation. The NEC, while not explicitly forbidding the described daisy chaining approach, sets forth specific guidelines for wiring practices. These guidelines are designed to ensure safety and prevent potential hazards. When wiring electrical systems, adherence to these codes is paramount. The inspector's concern stems from potential issues arising from the wiring configuration. The creation of parallel paths by skipping fixtures can lead to unequal current distribution and potential overloading of certain conductors. This can result in overheating, insulation damage, and even electrical fires. Additionally, the loop created by returning the current to the initial fixture introduces the possibility of impedance imbalances. Impedance, a measure of opposition to alternating current, can cause voltage drops and inefficiencies in the circuit. If the loop resistance is excessively high, it can trigger the circuit breaker, disrupting power supply to the fixtures. Understanding these underlying principles is crucial for proper electrical installations. The alternative solutions provided offer safer and more reliable alternatives to the problematic daisy chaining method. Using junction boxes ensures that each fixture receives its own dedicated wiring from the panel, preventing parallel paths and potential imbalances. This approach promotes even current distribution and minimizes the risk of overloading conductors. Daisy chaining without skipping fixtures maintains a linear flow of current, reducing the likelihood of impedance imbalances and voltage drops. This method also simplifies troubleshooting and maintenance, as each fixture is directly connected to the preceding one. In both alternative solutions, proper wire sizing, insulation, and grounding techniques must be employed to ensure compliance with the NEC. Wire sizing should be based on the ampacity of the circuit, considering the load imposed by all connected fixtures. Insulation should be appropriate for the voltage and environmental conditions to prevent electrical leakage and shorts. Grounding provides a path for fault current to flow safely back to the source, minimizing the risk of electrical shock. In conclusion, while the NEC may not explicitly prohibit the daisy chaining method initially described, it is essential to consider the potential safety hazards and code violations that can arise from this configuration. The inspector's concern is valid, and the alternative solutions provided offer safer and more compliant alternatives. By adhering to the NEC and employing proper wiring techniques, electrical systems can be installed and maintained to ensure safe and reliable operation. Understanding electrical codes and standards is not just about following rules, it's about protecting people and property from the dangers of electricity. Always consult with a qualified electrician or electrical engineer when designing or modifying electrical systems. Their expertise can help ensure that installations meet all applicable codes and standards, minimizing the risk of electrical hazards. Let's also think about the practical implications of these wiring methods in real-world applications. Imagine a large office space with numerous 2x4 fixtures arranged in rows. In such scenarios, efficient and code-compliant wiring is crucial for ensuring adequate lighting and preventing potential disruptions. The described daisy chaining method, while seemingly convenient, can create significant challenges in terms of maintenance and troubleshooting. If a fault occurs in one fixture, it can potentially affect the entire row, making it difficult to isolate the problem. The alternative solutions, such as using junction boxes or daisy chaining without skipping fixtures, offer greater flexibility and ease of maintenance. With junction boxes, each fixture can be isolated and repaired without disrupting the operation of other fixtures in the row. Daisy chaining without skipping fixtures simplifies the wiring layout and makes it easier to trace circuits and identify potential faults. Furthermore, consider the long-term implications of different wiring methods on energy efficiency. Efficient wiring can lead to voltage drops and increased energy consumption. This can result in higher electricity bills and increased carbon emissions. By employing code-compliant and energy-efficient wiring practices, businesses and homeowners can reduce their environmental impact and save money on energy costs. Regular inspections and maintenance of electrical systems are essential for identifying and addressing potential problems before they escalate into major hazards. Electrical panels, wiring, and fixtures should be inspected periodically for signs of damage, wear, and tear. Any issues identified should be promptly repaired or replaced by a qualified electrician. In addition to code compliance, consider the aesthetic aspects of electrical installations. Neat and organized wiring not only looks professional but also makes it easier to trace circuits and identify potential problems. Proper cable management techniques, such as using cable ties and raceways, can help keep wiring tidy and prevent damage. Remember, electrical safety is not just the responsibility of electricians and inspectors, it is the responsibility of everyone. By educating ourselves about electrical hazards and following safe practices, we can create safer homes and workplaces. Always turn off power at the circuit breaker before working on any electrical equipment. Use properly insulated tools and equipment. Never overload electrical circuits or extension cords. Avoid using damaged or frayed electrical cords. Keep electrical outlets and switches dry. If you are unsure about any electrical task, consult with a qualified electrician. They have the knowledge and experience to perform electrical work safely and in accordance with applicable codes and standards. Staying informed about the latest electrical codes and technologies is essential for anyone involved in the electrical industry. Continuing education courses, industry publications, and online resources can help electricians and other professionals stay up to date on the latest developments. Furthermore, consider the impact of emerging technologies on electrical wiring practices. The increasing popularity of LED lighting, smart home devices, and electric vehicles is driving the development of new electrical codes and standards. Electricians need to be familiar with these new technologies and how to safely and effectively integrate them into electrical systems. LED lighting, for example, has become increasingly popular due to its energy efficiency and long lifespan. However, LED fixtures often have different wiring requirements than traditional incandescent or fluorescent fixtures. Electricians need to be aware of these differences to ensure proper installation and operation. Smart home devices such as smart thermostats, lighting controls, and security systems are becoming increasingly common in residential and commercial buildings. These devices often require network connectivity and specialized wiring. Electricians need to be familiar with networking concepts and wiring techniques to install and configure these devices properly. Electric vehicles are becoming more prevalent as concerns about climate change and air pollution grow. Charging electric vehicles requires specialized charging stations that can deliver high levels of power. Electricians need to be trained to install and maintain these charging stations safely and in accordance with applicable codes and standards. In conclusion, electrical wiring is a complex and ever-evolving field. By staying informed about the latest codes, technologies, and best practices, electricians and other professionals can ensure that electrical systems are installed and maintained safely and efficiently. Remember, electrical safety is not just a matter of compliance, it's a matter of protecting lives and property. Prioritizing safety and adhering to the highest standards of workmanship will help create a safer and more sustainable future. The importance of proper grounding cannot be overstated. Grounding provides a safe path for fault current to flow back to the source, minimizing the risk of electrical shock. All electrical equipment and wiring should be properly grounded in accordance with the NEC. Grounding electrodes, such as ground rods or ground plates, should be installed in accordance with code requirements. Grounding conductors should be properly sized and connected to the grounding electrode system. Regular inspections should be performed to ensure that grounding connections are secure and free from corrosion. Surge protection is another important aspect of electrical safety. Surges or transient overvoltages can damage or destroy electronic equipment. Surge protective devices should be installed at the service entrance and at sensitive electronic equipment to protect against surges. Surge protective devices should be properly rated for the voltage and current levels of the electrical system. Regular inspections should be performed to ensure that surge protective devices are functioning properly. Arc fault circuit interrupters, or SIs, are devices that detect arc faults, which are a common cause of electrical fires. A SI should be installed in branch circuits that supply bedrooms and other areas where arc faults are more likely to occur. A SI should be tested regularly to ensure that they are functioning properly. Ground fault circuit interrupters, or GFCIs, are devices that detect ground faults, which can cause electrical shock. GFCIs should be installed in bathrooms, kitchens, and other areas where water is present. GFCIs should be tested regularly to ensure that they are functioning properly. Electrical panels should be properly labeled to identify the circuits that they control. Circuit breakers should be clearly labeled with the loads that they serve. Panel schedules should be updated whenever circuits are added or modified. Proper labeling makes it easier to troubleshoot electrical problems and prevents accidental disconnection of critical circuits. Extension cords should be used only temporarily and should not be used as a substitute for permanent wiring. Extension cords should be properly sized for the load that they are carrying. Extension cords should be inspected regularly for damage or wear. Damaged extension cords should be replaced immediately. Multi-outlet power strips should be used with caution. Power strips should be properly rated for the load that they are carrying. Power strips should not be overloaded. Power strips should be inspected regularly for damage or wear. Damaged power strips should be replaced immediately. Electrical work should be performed only by qualified electricians. Electricians have the training and experience to perform electrical work safely and in accordance with applicable codes and standards. Hiring a qualified electrician ensures that electrical work is done correctly and safely. Permits should be obtained for all electrical work that requires a permit. Permits ensure that electrical work is inspected by a qualified inspector. Inspections help to ensure that electrical work is done in accordance with applicable codes and standards. In conclusion, electrical safety is a critical aspect of protecting lives and property. By following safe practices, adhering to applicable codes and standards, and hiring qualified electricians, we can minimize the risk of electrical hazards. Electrical safety is everyone's responsibility. The NEC, or National Electrical Code, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is updated every 3 years by the National Fire Protection Association, or NFPA. The NEC is widely adopted by states and municipalities as the basis for their electrical codes. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for electricians, inspectors, and other professionals in the electrical industry to be familiar with the NEC. The NEC is a complex document, but it is well organized and easy to navigate. It is divided into chapters, articles, and sections. Each section provides specific requirements for electrical wiring and equipment. The NEC is not a design manual. It provides minimum requirements for electrical safety. It is up to the designer to determine the specific requirements for a particular installation. The NEC is constantly evolving to keep pace with new technologies and safety concerns. Electricians and other professionals in the electrical industry should stay up to date on the latest changes to the NEC. The NEC is available for purchase from the NFPA and other sources. It is also available online through subscription services. The NEC is an essential resource for anyone involved in the electrical industry.